Hi everyone, this is John Wen. Today is January 20th, 2021. Hope you've enjoyed a great week in the past week. And here is a video. I'm going to go through the research item in the past week. As you can see from the highlights, I was still working on the deep learning workflow. And besides that, I worked closely with SPI for several nights on the DataView 2.2 cloud computing service, because there was some issue to run the workflow on the Amazon EC2 in DataView 2.2, but after several nights work, now the DataView 2.2 can successfully provision VMs as well as run the workflow on Amazon EC2. So maybe after I get a chance to update the code in GitHub, I will make a tutorial video on how to update to latest DataView as well as run the workflow on the Amazon EC2. So back to the deep learning workflow. In the past week, I was working on to construct a new network as a task in DataView 2.2. And the good news is that I've done it successfully, which means the implementation has been complete. So which involves amount of time on the CUDA coding as well as a lot of time in debugging. For example, today I spent almost a whole afternoon in the debugging. Finally, I find out where was the issue and fix that. So here is the highlights. There are two files, which is main file for the task, which is called the CUDA neural network net.java. It wraps the simple neural network as a task in the DataView. It will run on GPU, which has one input port as the neural network specification. Also, it has one output to predict the score and output that data. And for the workflow, we wrap up this task into that workflow, and the workflow also takes one input and one output, which is a file of the specification as well as a prediction score as output. Maybe it's more clear to show you in the Eclipse. So here is a code I was working on, which is a CUDA neural network net. This is a task extend the task class, and in the function constructor we have one input and one output. I also have a helper method which is read specification. So I put the code here to make the run method a little bit shorter. So we also have three steps as usual in the run method. The first step is going to read the input from the input ports. So I use this readspecs method that is able to help us to get a hash map, return from this method that is a specification we want to construct a new network. And the second step is going to process the input data. So that means we're going to construct a new network, and then we're going to do the training and testing. So I also use another helper class which is called the call native as task. So this one will help us to locate a DLL file which I generated ahead of time. But keep in mind there are a lot of coding on CUDA behind this DLL. There are a lot of debugging issue as well because they are two separate systems. As long as I found some errors beyond the JNI or Java environment, I have to spend a lot of time in the CUDA to try to figure out what is the issue. But the good thing is that I finally figured all those things out, so it has been successfully run. And let's get back to this task file. And the final step is we're going to output. So we're going to get a file name and write that into the file. And also, if we take a look at the workflow, this one will be very simple because we just wrap the task, the CUDA neural network net task inside. So we have two steps. The first step is a function constructor, and then we do the design, which is going to add a task and add edges between the inputs and the task and outputs of the task as well. So you can see from here, this is a input text. The first column is a line number, so we can just ignore that, and this means layer number. And for the second part is the specification. 0 means a linear layer, 1 means a ReLU layer, and 2 means a sigmoid layer. And for the linear layer, we have extra digit to represent specification. The second digit represent input neuron of the linear layer. So here means we have 2 input neuron and 30 output neuron. And this one means we have 30 input neuron and 1 output neuron. So after we done that, we put the workflow in the test.java and we can run it. So if we run that here, we can successfully see something happens. So here is a workflow we are going to run, and from the console you will see that it has been successfully run. For simplification, I decrease epoch from 1000 to 5, so that will take very little time to finish. So you can see the epoch 0, we print out every 100, so that means we only print out the first time. The cost is about 0.66, and accuracy is what we get when we testing the data, when we do the testing on the testing data. And the execution time also reflected here. So while we refresh the working directory, you will find that the output file also resides in this folder. So this is prediction score.txt, and you will see that prediction score is 0.5, so which is exactly consistent here. So I think we get a good start, and this can be a base for the further research. So I think that's pretty much for this video. Thank you very much. Hope you enjoy. And other than that, see you next time. Happy coding.